Hello, everyone. I'm Dr. Rory Cooper, and I'm the director of the Human Engineering Research Laboratories and the FISA Foundation and Paralyzed Veterans America Distinguished Professor of Rehabilitation Engineering at the University of Pittsburgh, as well as a senior research career scientist for the Department of Veterans Affairs. If you ever have the opportunity to visit Pittsburgh, you're welcome to come and see us. We are located in the Research Park at Bakery Square, which is a beautiful old converted Nabisco cookie factory. I am myself a person with a disability, a wheelchair user due to a spinal cord injury I sustained while serving in the United States Army in Europe. And I subsequently received all of my education in engineering with a disability and prior to the enactment of the Americans with Disabilities Act. There are a large number of people with disabilities in the United States. In fact, it is the largest minority group in the United States, representing over 50 million people. My work focuses primarily on these portions of the population, mobility being one of them, and independent living and self-care, kind of the primary areas. And I'll give you a little overview of that, as well as some of my philosophies.
I tell people frequently, and I really mean this, it's kind of like Willy Wonka in the Chocolate Factory. I get to play with robots and all these technologies.
Our mission is to apply engineering and advanced technology to improve the mobility and function of individuals with disabilities. A large number of them are our veteran population.
Every day that you come in, there's this kind of wonderful energy here.
From students to staff to faculty, we wouldn't really be living up to our mission if we didn't include people with disabilities in all aspects of what we do. Our vision is a world where everyone with a disability can participate on a level playing field to their greatest extent possible.
I've got a disability, I certainly wouldn't think of myself as disabled, but it was having a huge impact on my life, on my wife and my children. We can do better than that. We have to do better than that. So I work here because I want to give everyone an equal opportunity to whatever they want. Disability shouldn't be the thing that prevents them from getting those things.
So I hope you enjoyed that little video clip of Hurl and some of our people, and recognize that a large number of people with disabilities and various technologies, which I'll try to cover some of those. I do want to point out two things. I think that we need more role models of people with disabilities in engineering and science. The Institute of Electrical and Electronics Engineers recognized this in 2014, that we needed more engineers as to be our heroes, like sports heroes and other in media. One of the things I think is important is to encourage young people with disabilities to pursue careers in science and engineering. And I had the good fortune a while ago to contribute to the magazine Whiz Pop Bang, which is for middle schoolers, not just middle schoolers with disabilities, but all middle schoolers. And the topic was on wheels. And I was fortunate enough to be selected as the distinguished scientist or engineer to represent wheels, which they represent. Each month they come out with a new scientist, typically without a disability. I jumped at the chance because middle school is a branching off point for where kids with disabilities have the opportunity to become scientists or not. All kids to some degree, but for kids with disabilities, often point if they choose a different fork in the road, their careers in science and engineering may be severely limited later on. I also think, given the topic of participatory action, design, and engineering, that it's important to get the message out in the mainstream when possible, because there just aren't that many scientists and engineers with disabilities, especially those with visible disabilities. And often people underestimate the abilities and the potential to study in this field. If you really get the chance, to go mainstream, this is the U.S. Patent and Trademark Office, starting in 2012, a collectible card series to honor inventors that have contributed to the United States through their invention across all times of history, of people that have changed America socially or economically through their inventions. You can see some of the people that you might recognize, such as Thomas Edison, Nicholas Tesla, Temple Grandin, or Abraham Lincoln. I was fortunate to be selected as the 28th person to receive such a trading card. And this is great because it reaches out to kids and even adult collectors to learn about science and engineering and invention, and to also learn that assistive technology and people with disabilities can be important contributors to those fields. So let's get to the kind of the primary purpose of this talk, which is participatory action design and engineering paradigm. Now we're very focused on sort of that approach applied to devices for individuals with disabilities and medical devices. And so we start with user need identification through storyboarding. We mock up systems, we collect initial user data, and then we'll collect technical data like ISO testing and other RESNA testing, other benchtop type testing. We'll develop prototypes, we'll look at their capabilities, maybe on a field test, maybe do larger demonstration studies, and hopefully get approval or licensure, and then it becomes standard of care. But what's critical is throughout this entire process is to have user engagement from conceptualization all the way into community participation, employment, and living healthy. So let's get to dig into this just a little bit more. So one thing is that the number of the national academies have done 2 reports, and there's been other papers published showing that technology promotes social mobility, health, and participation among individuals with disabilities. And this is true of our veterans community as well. Veterans with disabilities share many of the same needs and desires as individuals who, as Americans who have not served in the military and have a disability, and have some unique requirements or needs as well. And that's been demonstrated in at least 2 books and several papers for promoting successful integration, and also Warrior Transition Leader Medical Rehabilitation Handbook. Interestingly enough, it's the Canadians have looked at this problem as well, and this challenge as well, and come to similar conclusions, which adds some sort of base validity. I would like to put out there, though, that things are not all rosy. There is a tremendous need to increase the accessibility and participation of students with disabilities in the STEM fields, and to remove barriers for them to succeed in STEM fields. Unfortunately, many students with disabilities wind up serving as note takers and observers, and we need to address that. And there has been, there's physical barriers, there's attitudinal barriers, there's knowledge barriers, and there's social barriers that all have to be addressed. The National Council on Disability supports the participatory action design and research paradigm. It here is quoted from a recent report by the National Council on Disability. And specifically, I'm going to dig into some work that we've recently started on self-driving cars or autonomous vehicles and transportation systems. This magazine, Diversity, that's 2 of my former students, Dr. Jonathan Duvall and Dr. Brendan Davler. So it's exciting to see individuals with severe disabilities be mentored and go on to succeed. In Voice of the Consumer survey related to transportation data, you can see that 48% of respondents were interested in self-driving vehicles, and another 25% were interested in general driving assistance. So that represents nearly 75% of those people that commented. Comments related to levels of autonomy for vehicles present both a tremendous potential and a tremendous risk for individuals with disabilities. Transportation is a key factor in employment and accessing healthcare and participating fully in society. But if self-driving or autonomous vehicles are not accessible, they could actually create barriers by supplanting currently accessible transportation systems. So recently, I worked with a group in our Human Engineering Research Laboratories to do a literature review related to autonomous vehicles and transportation systems. In the end, we found 27 scientific papers and 3 important papers in the gray literature. Most of the research is related to older adults. So we need to broaden the scope of research to look at younger populations and more diverse populations of individuals with disabilities. But it does show that the entire trip, from booking a trip to finding the vehicle to where the vehicle parks, accessing the doorway on the other end, and locating, are all important. The quality of the ride, if there's any breakdown during the trip, all of those are important. And they need to be tailored to individuals' preferences and needs. So what their capabilities are, what their preferences are, how safe they feel in the vehicle are all important, very important factors, among others. There needs to be more clear guidance on accessible design. It's an area that is not, it's understudied in the vehicle literature. And more planning and policy are needed, and there's a number of research gaps that's still to be filled, and also those have policy implications. So we look at another voice of the consumer. So we did a large survey, over 1,000 individuals, to sort of define the priorities that consumers have for assistive technology related research. And the consumers came back with 5 different areas. I won't go into detail into the subcategories. You can see those on the slide. But the main categories are participatory action, design, and engineering, which went into like universal design and education and standards, advanced wheelchair design, smart device applications, like you would see with wearables and smartphone usage and apps, human-machine interfaces, so better interact with technology, and assistive robotics and intelligence systems. So what's clever is that consumers, they have a pretty good idea, and it relates pretty well to the scientific literature on what people want to have people work on. Now, scientists also tend to work on these things, but also work less on the application space, but on the fundamental science space of looking at biomechanics and neurosystems that lay the foundation for these type of work. So that makes sense. It's also interesting that consumers pointed out, as well as clinicians, interestingly enough, a number of things that actually were commercially available or research that was widely available. So we wanted to know where people got their information sources. So we did another study of individuals, and we found they really fell down into 3 clusters. You can see the results of a K-cluster analysis in the upper left corner of the slide. You can see on the upper right corner the various predictors of importance. Interesting enough, the veteran status has a huge impact on information sources, which you might think is surprising, but if you realize that the VA has a different mechanisms for providing technology and a more holistic view of the provision of technology than other payers, it starts to make sense. But basically it fell into 3 groups, what we called engaged, disengaged, and prefers internet and family and friends. And that the military actually was kind of split between engaged and disengaged, almost evenly so. Probably the most interesting finding from this is that the engaged group tend to be the oldest group and mostly individuals with spinal cord injury, where the disengaged group was younger, more newly used device, and largely had multiple sclerosis and a lower income. So I'm going to shift gears here a little bit and talk about some research that we've done that was driven by consumer needs. So years ago, I discovered that many individuals who participate in wheelchair sports, especially wheelchair racing, pushed hundreds of miles per week and really didn't develop very high incidence of repetitive strain injuries, so carpal tunnel syndrome and rotator cuff injuries. But individuals who propelled their manual wheelchairs and didn't participate in sports and recreation had pretty high incidence of carpal tunnel syndrome and rotator cuff injuries, on the order of about 80% within 5 years. So that led to the development of the smart wheel. Show my arrow here, it's in the upper left corner. It measures the push reinforcements and moments. There's a racing chair version you can see as well. That's got kind of the white hub with the markings on it. We did ultrasound images, where you see the region of injury, that's the biceps tendon. And then the other image where I have the arrow going over is the carpal canal for the carpal tunnel syndrome. And We're able to do these ultrasound images showing that you could see edema in the biceps tendon or compressing of the median nerve pre and post heavy activity. And that led us to invent other several patented inventions, which became on the market as a natural fit in the surge and also as the path lock, circled in green, which is a locking mechanism that helps keep the wheelchair going straight. It eventually led to preservation of upper limb function following spinal cord injury clinical practice guidelines. What's wonderful is that now the incidence of rotator cuff injuries and carpal tunnel syndrome among individuals who use a well-fitted wheelchairs and ergonomic push rims is about 20% within 5 years, which is probably what you could expect in making modifications in the wheelchair. After that, you have to make modifications in other activities such as transfers. That's just the circling the median nerve. A clinical need that we had identified of people getting power wheelchairs with power seat functions, but their condition not improving. And so we did a series of experiments to identify that people would use their power seat functions, but not necessarily as instructed. The idea with the virtual seating coach was to use the advances in technology, but first onboard computing, later with a smartphone technology, to provide that coaching in real time, contextually aware, all the time available to the user, and to provide that data to the cloud, one, so those algorithms could be improved based on what was learned, as well as share that data with clinicians in order to improve their clinical practice and eventually improve clinical practice guidelines. And ultimately the goal is that we use the technology interacting with the user to help the user get the maximum benefit from the technology they're using. So we're also working on a manual that is available commercially by ProMobile, used by about 50,000 individuals. We're also working on a manual wheelchair version, and you can see on the bottom right corner the K-cluster analysis as well of looking at clustering algorithms of whether the person's doing a leftward lean, a rightward lean, a forward lean, or a wheelchair push-up. And then we can do that to coach people to perform pressure reliefs in their manual wheelchairs and hopefully reduce pressure injuries. And the virtual seating coach for power wheelchairs has at least in research studies and now initial usage on the market shown that it can reduce pressure injuries among power wheelchair users with power seat functions by about 25%, which is pretty significant. Some people are not likely to follow directions, be adherent to clinical practice guidelines, even with a virtual seating coach for various reasons. So we've been working with the University of Texas Applied Research Institute on an active cushion using a simulated reference seat that's adopted from the ISO and RESNA standards. On the upper right corner is the cushion itself. And then in the row below that on the left is the cushion being loaded. In that second row on the right side, you can see the pressures from the internal pressure measurements as well as the pressure mapping external pressure measurements, and see reasonably good agreement. The internal pressures actually make more sense, are probably more accurate. If you look at the bottom row, we've got the cushion unloaded. A person simply sits on the cushion. We offload the ischial tuberosities, which is kind of the standard way that most active cushions work and most passive cushions work. And then if we look in picture D, you see the pressure redistributed over the maximum surface. And that actually does a better job of eliminating any of the yellow and red areas, which reduces the risk for pressure injury.
Hi, my name is Joshua Zhong. I am a researcher at the Human Engineering Research Labs. My research project is focused on the performance evaluation and the user interface of the assistive robotic manipulators. So the assistive robotic arms is that a robotic arm can be mounted on the wheelchairs, and that can assist wheelchair users or people with a disability to do some daily tasks using the control interface. So the reason we developed the interface is that we have tested with the current robotic original interfaces, and a lot of users have difficulty learning those, either memorize the keys or memorize the command or combination of different keystrokes. So the interface we developed kind of reduce those frustration, so they can quickly learn how to control the robot, and they can do the task just within 10 minutes. There was one veteran look at our robot, and he was so excited, and he said he just point to the robot and saying to the caregiver, "That's what I want." So I think the robot would be really helpful for people sitting in a chair and still want to achieve something for their lives.
Hey, good evening, DAV. Dan Clare. I'm here at the National Disabled Veterans Winter Sports Clinic, a great event that we do with the Department of Veterans Affairs. And I'm here in a room where very important. Dave talked to Dr. Cooper. They got together and they came up with this device. Tell us about it, Dr. Cooper.
Yeah, it's basically an adapted computer mouse that we designed and actually patented to be compatible with a prosthetic hook. So it's got like Dave's using right now, it's got kind of a dead zone, neutral zone, and then it's got the left button, right button for left click, right click. It allows you to also drag and click, but also for maneuvering, left click. So that you can use a mouse just like anybody else.
Dave, how's it different for you to try and use something?
Oh, it's much better than, I used to use the eyeglasses with, it tracks your pupils and then you use voice assistant, but this is just like using a mouse again almost. I mean, it's very mobile. We found on the mouse pad we're going to do something, but, the buttons are right here. We're going to tighten up that little hole there so it's not as much wobble, but this will work excellent.
It's just a little refining and we're there. And
This is our robotic assisted transfer device. You can see the pictures on the left, and the middle of the video is marked transfer as a dummy. This helps attach to the wheelchair. It can move on the left to the right side or park in the back for transport. Allows people to take their transfer device with them when they go to the mall or stay at a hotel or go with friends. Reduces quite a bit of the lifting work that's required by caregivers and safer by users. There are some individuals who getting a sling underneath them or transfer is difficult, so we've been working with Next Health to come up with a zero lift transfer device. So this is a power wheelchair, and Josh is going to help transfer Jessica here. Jessica would be able to do this transfer independently, and it basically, we try to match the kinematics of the wheelchair movement, so the wheelchair kind of tilts back, uses the bed as the backrest. There's a conveyor on the bed, and it all can be controlled with a phone or a tablet for these movements. The other advantage it has is that allows a person to reposition themselves in bed. So if they slide down, which is common, when we demonstrated this to the wife of one of the veterans here locally at a veterans care facility, long-term care facility, she requested that they get one provided for her husband, and we were able to arrange to have one delivered to them, and she was able to take her husband home after 3 years of living in a nursing home, which is tremendous benefit to the family and to the individual. This is Dr. Jung-Bae Kim, was a student of mine. He's now a professor at Yonsei University. He has high tetraplegia, and because he's using our Reebot to climb an 8-inch curb. The Reebot is another one of our patented technologies, and it uses our variable compliance joystick algorithms, which you can see the patent for that up in the upper right corner. Dr. Kim also, you can see he's able to let go. It stays soft. As you can see from the video, has very little hand function and is able to work and use the device independently. You could also descend it up to an 8-inch curb. You could climb a curb of any height up to 8 inches. Could actually go higher, but the process is stable, quasi-statically stable the entire time, and reversible for an 8-inch curb. Also, you can see by putting the actuators down below, you still get seat tilt, seat recline, lateral tilt and recline, and you could have an eye-level conversation. I would like to point out in the bottom right-hand corner, one of my favorite pictures is all three of those are current or former students of mine, all of them wheelchair users, at least full-time or part-time, due to spinal injury or disease.
You have to get up to the slide. And also the rides in the water parks typically just aren't good for someone without balance. So that's just in general water parks a challenge.
And being in a power wheelchair makes it even more difficult. These wheelchairs run on electricity, and when water comes in contact with them, the results can be shocking. So how do you build a water park that all kids can enjoy? That's the question Gordon Hartman had. He runs the world's first accessible theme park, Morgan's Wonderland in San Antonio.
We had to come up with a wheelchair that would allow for it to get wet and still be able to move about through the use of someone's ability to use a joystick.
That's when he discovered the work of Dr. Rory Cooper at the University of Pittsburgh School of Health and Rehabilitation Sciences. Dr. Cooper is world-renowned for numerous patents and inventions when it comes to wheelchair technology. He's dedicated his life to improving assistive devices for people with disabilities.
I found Dr. Cooper from the first conversation we had on the phone as a person who really wanted to work hard at ensuring that this idea that we had of developing this chair, which would truly be revolutionary.
Gordon and I have the same vision. That's a world where everybody can participate together, so that people with and without disabilities are on the same playing field. The idea is that, hey, an air motor with air tanks, if it's feasible, may provide with a much lighter power chair, much more environmentally friendly, that doesn't need to have the batteries replaced.
And from that idea, a new chair, short for pneumatic chair, was born.
The new chair is powered strictly by compressed air. There's no batteries, so that makes it waterproof. We can recharge it in as little as 10 minutes. Unlike current battery wheelchairs that could take up to 8 hours, it could revolutionize the wheelchair industry.
Brandon Davler, a current graduate student at Pitt School of Health and Rehabilitation Sciences, is a researcher studying under Rory Cooper. Their team works out of the Human Engineering Research Laboratories, where they modeled and built the new chair. The chair that makes a challenging trip to the water park, well, fun.
I like to have the freedom to run around.
It was rewarding to see just how he lit up and the enjoyment that he got out of going through the sprinklers and the water.
He wants to be independent. Quite frankly, we let him go for 30 minutes by himself, and that's what he wants.
And Rory thinks children without disabilities who witness this independence will be influenced too.
So thank you very much for listening to me today. I hope you enjoyed it, and I hope to see you soon.